This is homework 1.3.1, where we are practicing semantic validity. And what semantic validity is, we're going to assign truth values to each of these propositional parameters in every single way possible. So every single combination, I should say, possible. And based on those combinations, we'll see what they do to the premises. And every time we see we have two, they make the premises, both all the premises true, we'll check the conclusion and see if the conclusion is true. And if it's ever false, we'll know that the premises never don't prove the conclusion, because there's at least one possible time where that you have the premises and the conclusion is false. If there's never a time where the conclusion is false, if every time all the premises are true, the conclusion is true, then we know that the premises prove the conclusion. Because there's no way you can have the premises be true and not have the conclusion be true. You may wonder what happens if the premises are false. Like what does that do to the conclusion? Well, we don't care if the premises are false, right? What I'm saying is, if I have this premise and I have this premise, it shows that this premise has to be true, right? So if I have this premise and this premise, meaning if these two premises are true, then the conclusion has to be true. If the premises are false, I don't care what the conclusion says, because that's not my problem at that point. The problem is, do these premises lead to the conclusion, right? So I'll assign all the truth values every single way possibly can, and I have this Excel spreadsheet set up so that when I put, for example, like a 1 over here in the P column, then these formulae over here will have 1s for each of the P's. If you really were high speed, then you could put a formula in here for the if-then statement, based on these rules over here, but I didn't do it because I wanted you to see me actually use these rules. So let's go ahead and put together all kinds of propositional parameter truth values. So first I have the first combination I can have, P can be true and Q can be either true or false, right? And if P is true and Q is true, R can be either true or false. And P is true and Q is false, R can be either true or false, right? And same thing here. P can be false and Q can be true or false. If P is false and Q is true, R can be true or false. If P is false and Q is false, R could be true or false. You may see kind of a pattern here, and the way it always goes is the last one is 1 0 1 0 1 0, and then 1 1 0 0 like that, and then 4 1s 4 0, and then it just it would expand from there, if we had a fourth propositional parameter. Anyway, so that's this has all been distributed out here. If I say P is true, then P is gonna be true here, and P is gonna be true here. So now what we're doing, we're looking at the whole formula, if P then Q, right? And we're going to say, when is if P then Q true based on these truth assignments? These are all the possible truth assignments that we can have based on this setup right here, right? My rule over here says, if P then Q is true if either the antecedent P in this case is false, or the consequent Q in this case is true. Otherwise, it's false, right? Otherwise, it's 0. So what that means is, if you you kind of remember what the if-then means. The if-then means if you have the first one, then you're gonna have the second one. The only way that can be false is if you have the first one but you don't have the second one, right? If P is true but Q is not true, Q is false. So that's what this rule actually says. This rule says that this thing is false, when anytime you have 1 for the first one and 0 for the second one. Otherwise, it's true, right? And that it may be kind of hard to see there, but if the first one, A in this case, or P in this case over here, is ever false, right, the whole thing is true, right? And if the consequent Q, or B in this case, right, is true, then the whole thing is true. That covers all three other possibilities for truth assignments here. So, for example, in this case, the second one is true. Q is true, right? So this whole thing is true. And so I'm going to put my truth, the truth value of the whole formula underneath the operator that I'm worried about. So here, and then this one is the same one as that last one. For this one, it's not the case that A, the first one, P, or over here, is true, right? It's false, rather. It's true, right? And it's not the case that the consequent, Q, is true, right? So I have to go to the otherwise. Otherwise, 0. And then the next one is 0, too. So in the last four, I see that the first one is 0, is false. So I know the last four are true, too. So that's the way, oops, I don't love it. That's the way this whole thing is. This is the truth value you're looking at. And remember, and you should remember that it's this one because the P's and the Q's, those are just the individual propositions that are getting connected by the operator. So the whole thing is connected by this operator. So that's the one that I'm looking at right here. This for the whole formula, right? So this is the truth value we're worried about. When we're going to look at it later, I will highlight that just to keep us clear. And then we'll do the same thing over here. This is another if-then statement. Remember, if-then statements, they're only false if you have the first one, but you don't have the second one. This one says if you have Q, then you have to have R. So if you have Q and you don't have R, then it's false. So I have right here the case where you have Q but you don't have R, so that's false. I'll look for another 1, 0, and I see it right here. The rest of them are not like that, so I'll make the rest of them true. So again, this is the column that I'm worried about. And then the last thing, same thing. I'll look for a 1, 0. I got one here. I got one here. Everywhere else is true. Is ones. So I'll highlight that one once again because that's what I'm worried about. So now here we have premises over here, conclusion over here. I want to see, is it ever a case that the premises are true and the conclusion is false? So the first one, I have the premises are both true and the conclusion is true. Good. I don't have to worry about that one. Here, if you have the premises true, then the conclusion is true. Sweet. This one I look at and I say the premises are not both true, right? One of the premises are false. So I don't really care what this says, right? I'll black this one out because that doesn't really apply here, right? Same thing here. Premises are not both true, so I don't care what the conclusion is. I'm not even gonna look at it. Here again is another one down here, by the way, where the premises is false. One of the premises are false. And over here you have premises true, premises true, premises true. And all of these, you see the conclusion is also true. So for all of these ones where the premises are all true, the conclusion is also true. So this is valid. And if you look at it, it kind of makes sense. If you have P, then you have Q, right? And if you have Q, then you have R. So let's say you have P. If you have P, it's going to give you a Q, right? So then that Q is going to give you an R. So if you have a P, you're going to have an R, right? So if P, then R. That's what that says. So the first one is valid. All right, let's do the next one. If P, then Q. If R, then Q. Does that entail that either P or R, then Q? And just looking off of the bat, this should make a little bit of sense, right? This says if you have P, then you're going to have Q. This says if you have R, then you're going to have Q. So if you have P or you have R, either way, you're going to have Q. And that's what this says. If you have P or you have R, either way, you're going to have a Q. So this should be valid. Let's make sure. This is the way that my possible assignments can look, right? Oops. Oh, sorry about that. I don't know why this is difficult. For some reason, I can't get it. All right, there we go. All right, so those are all the possible assignments. Again, here's an if-then statement, right? And the if-then statement is only false when you have the first one, but you don't have the second one. So I see that right here, and I see that right here, 1, 0. The rest of them are true. So I'll go down there, like so. And then I'm going to highlight this. Now the highlighting part is not standard. I'm just doing that so you can see it. Same thing here, another if-then statement, right? So I'll look for the false ones first. Now I'm going to look for the true ones. The rest of them, I should say, are true ones. Alright. And again, I'll highlight them. And then, alright, now we have a formula where you have two things, right? You have the P or R, and then you have the if-then over here. So you may ask the question, which one do you do first? Well, if you start actually doing them, it's going to make sense which one you're going to do first. Because if you start doing the if-then over here, you're going to look over here and be like, well, which one am I using for the antecedent, right? the if then, remember, is false only when the antecedent is 1 and the consequent is 0, right? The first one is true and the second one is false. So if ever P or R is true and Q is false, then we know that the if then is false. But I don't know if the P or R is true or false because I just have the P's and the R's. So that means I have to do the P or R one first. I have to assign these values first. So yeah, we're always working inside out, inside parentheses out when we're talking about semantic validity. When we're talking about when we do the Tableau tomorrow, then it's going to be the exact opposite. We're going to be working outside in. But for this one, we're working inside out. P or R, here's my rule right here. It says the OR rule, it's true, A or B is true if A is true or B is true. Either way that A or B is true. And otherwise it's false. So if at least one of these two things is assigned one value, then the whole thing is assigned a one value. So I'll look at that. Here's a one value right here, one value over here, one value over here. Notice I don't even look over here because I know these are all ones over here. So I'm wasting my time if I look over there. Over here I see a 1. Over here 2 zeros, so I'm going to make this a 0. Because right, so it says otherwise 0 if they're not both 1. If at least one of them is not 1. Here's a 1 over here. That's true. Both of them are 0. That makes it 0. Okay, now here's to keep it straight, I'm going to highlight it in a different color. Let's see here. Let's highlight it in like a burnt sienna, right? I don't know what color that is. But this is because I'm not really worried about this for the whole thing. I'm just worried about this one, so I know what the whole the if then is. So these are these are the two columns I'm looking at right now. I'm saying if P or R is true and Q is false, then the if then statement is false. Otherwise it's true. So I'll look for places where P or R is true, and I have all of these places and this one too, right? So in all these places, P or R is true, and I look over here and Q is false in those places, in these two places right here. So these two times are when the if then statement is false. And over here I also have P or R is true and then Q is false. So this is another place. And the rest of them are true. The rest of them are ones. So now here's the column I'm worried about, right? When I'm looking at this whole thing, because now I'm going to say, are the premises true and the conclusion false? If I ever have that issue, then I have a problem. See, I do have conclusion false sometimes, but I'm worried about when the premises are true, is the conclusion possibly false? So let's look at that. Here the premises are both true, 1, 2, and the conclusion is true. Here the premises are both true and the conclusion is true. Here the premises are one of the premises are false at least, right? And down here too. So I don't really care what the conclusion is. I'm not even going to look at those. Here premises are true, conclusion is true. Here premises are true, conclusion is true. Here a premise is false, so I'm not going to look at the conclusion at all. Here the premises are true and the conclusion is true. So every time I have the premises true, the conclusion is true. This is valid. I'm going to take a break right here, and I'll do the next 3 in the next video.